Hello, everyone. So today I'm going to go through the Chapter 11 examples of rigor, and we'll kind of go through this step by step so you can see all the topics together. If you have any questions when the video is over, please email me, and I'd be happy to go through them with you. So let's take a look at number one. So this section just says rewrite each log in exponential form. It's not asking you to solve anything. It just wants you to rewrite it in exponential form. So what we do here to rewrite is I first try to identify the base of my log. In this case, my base is 3. Okay. Now, the number that it's equal to is always going to be the exponent to the fourth, and that's going to be equal to the argument of the log, which is 81. And that's it. You just have to rewrite it in exponential form. So again, for number 2, the base of my log is 9. It's equal to the 0, so that's my exponent. And the argument of my log is a 1. Okay? And then last but not least, the base of my log is 5. It's equal to the negative 2, and that's going to, the argument is 1 over 25. So that's how we rewrite it from logs to exponents and exponents to logs. Okay? Now, we're going to go the other way, right? So if I have a exponential function and I want to write that as a log, that means I'm going to start with the word log here. I'm going to use base of 2 of 64, and that's always equal to the exponent. Okay? So same thing for number 5. If I say the log, I'm going to use base 10 of 1 over 100, and that's always equal to the exponent, right? So translating from one form to the other. So I have the log, it's got a big base on here of 125 of 5 is equal to my exponent, which is 1/3. Okay? So this is translating from one form to the other, or rewriting from one form to the other. Okay? The second thing that we learned is how to expand logs and how to condense them, right? So we had 3 properties that we had to use. Okay? So I want to go through these 3 properties again. So anytime that you have a log of a product, so 2 and x to the 7th are two different pieces being multiplied together. So I'm going to write this as the log base 5 of 2 plus the log base 5 of x to the 7th. Okay, so anytime you have a product, we split it up into a sum of 2 logs. Now, any exponent that you have can become a coefficient. So there's no exponent in our first log, so that one would stay exactly the same. And then I'm going to have a 7 log base 5 of x. Okay, and that would be my answer. All right, that would be fully expanded. Now, for number 8, we have a natural log here. That doesn't change how we do anything, but we do have division, right? So division, we handle a little differently. We don't use addition, but instead we'll use subtraction. So I'm going to say the natural log of my numerator minus the natural log of my denominator. Okay, but then if you look at the denominator, you can see that it's a product of 2 things. So I can say the natural log of y minus the natural log of 3 plus the natural log of x squared. Now, what I am going to do here is I am going to kind of keep those last 2 things in parentheses, because remember, those are both going to be in the denominator. So I don't want it to look like I'm multiplying that last piece, because they're both going to go into the bottom. So then my last step is I do have an exponent. So I am going to write, let me get my pen working here, ln of y minus the natural log of 3 plus, and then it would be 2 times the natural log of x. And that would be my final answer. Okay? Now the last one, we don't really need to worry about those radicals. That won't be on your assessment during this time. Okay? But I do need you to know how the properties of logs work, how to expand them, how to break them down into simpler pieces. So let's take a look at number 10 and 11. So we're going to do the inverse here. We're going to, instead of expanding them, we're going to condense them. So anywhere where you have a coefficient, for instance, on number 10, we have two coefficients. Those are going to become exponents. So I'm going to have the log base 3 of 7 squared minus the log, excuse my bad writing here, let's get this working again, log base 3 of x to the fifth. Now, when you have subtraction, that's going to be division. So I'm going to say just log to the third of 1 time of what fraction? Well, 7 squared over x to the fifth. Now, if you wanted to write the 7 squared as just 49, you absolutely could. That wouldn't be a problem. Or I could accept it just like this. So when we condense, I'm going to change any of these coefficients. Okay. Again, I'm being a little fidgety here. So get things working. So we're going to change any of those coefficients to exponents in the very beginning. So I'm going to say the log base 4 of 2 to the 7th plus the log base 4 of x to the 5th plus the log base 4 of y to the 3rd. Now these are all being added together, so I know I need to multiply all of the insides. So I'm going to say 2 to the 7th, x to the 5th, y to the 3rd, and that would be my answer of everything condensed into just one log expression. Okay, so now I'm going to skip this portion. You don't need to worry about that, because what we're going to do is we're going to do all the different types of solving starting with number 15 on. Okay, so the last part, the target B of your test, is going to be solving log equations or exponential equations. All right. So one thing I want you to remember, whenever you're solving a log equation, we're going to use exponents to solve it. And if we have an exponential equation, we're going to use logs to solve it. So I'll show you how that works. The first thing that we need to know is what the base of our log is. So since the base is 5, I'm going to say 5 to the left power is equal to 5 to the right-hand side power. Okay, and when you have the base of your power matches the base of your log, those cancel. And I'm left with 3x plus 1 is equal to 5 squared, which we all know what 5 squared is. So I'm going to say 3x plus 1 is equal to 25. And I can subtract the 1, which gives me a 24. And if I divide the 3, I'll get x to be 8. Okay, so I know my answer to number 15 is 8. Now, we should check for extraneous solutions here. Remember, we can't have any negatives in our log. So I would say log base 5 of 3 times 8 plus 1 is equal to 2. So I'm going to get the log base 5 of 24 plus 1 is equal to 2. And the log base 5 of 25 is equal to 2. And if you did the log base 5 of 25 in your calculator, you would get 2. That does work, so I know that is the solution. Okay. Now, number 16 is different. We did one of these on, I think the video was advanced exponential equations, right? So we have powers on both sides, and what we want to do is we want to get those powers to have the same base. So I notice here on the left-hand side is 9 to the 2x. On the right-hand side is 81, but I can write that as 9 squared. 9 squared is still 81, and it's still going to be to the 3x minus 2 power. So I didn't change the value of anything. I just changed the way that it looks. 9 squared is still 81. But if you notice, now the left-hand side and the right-hand side of my equations now have the same base. So what I want to do is I want to kind of clean up this right-hand side. Whenever you have an exponent to an exponent, we need to distribute. So I would have to do 2 times 3x and 2 times the negative 2, which is going to give me a 6x minus 4. Okay, now if if the left hand and the right hand side of your equations have the same base, then we can just go ahead and we can solve the exponential equations, the equation created by the exponents. So I'm going to subtract the 6x I get a negative 4x equals a negative 4. If you divide the negative 4, I get x to be 1. But I want to check that. I want to make sure it works. So 9 to the 2 times 1 is equal to 81 to the 3 times 1 minus 2. So if I do that, I'm going to get 9 to the second equals 81 to the first. 9 to the second is 81. 81 to the first is still 81. And hey, that works. That checks out. Always, always check your answers to these. Plug them back in. Make sure you have the right solution. All right, so you can see ahead. I have a few more of these. I'm just going to keep going. Feel free to pause the video if you want to try to do any of these on your own. But I'm going to solve number 17. So we have another log equation, just like 15. But what I need to do is I need to get this log all by itself. So I'm going to subtract the 3. I'm going to say 4 natural log of a negative x is equal to 18. I'm going to divide the 4. Now, we're going to get a decimal here, and that is okay. I have my calculator here to help me, but you can use your phone. You can use whatever you want, but I'm going to use 18 divided by 4 is 4.5. Okay. Now, here's an old note that we said before. Natural log is the same thing as log base e. So to get rid of a natural log, we are going to use the base e. E is a number on your calculator. It's actually right by the division button. Okay, I think it's right above it. So when those cancel, I'm going to give myself a little bit more room here. I'm going to get a negative x equals e to the 4.5 power. Okay, now if I do e to the 4.5 power in my calculator, I got something like a negative x equals 90.017. And then if I divide the negative, I'll get a negative 90.017. And that would be my final answer. Okay. Now, if you check this, okay, when I plug it back in, it will work. I ran out of a little room on my sheet here. It will work. However, you might be slightly off because we did round our answer. So you might get a decimal very close to 21, but that's only because of rounding error. Okay. So let's take a look at number 18. If you look at 18, we have logs on both sides. Well, if I have logs on both sides, if the left-hand side needs to equal the right-hand side, we already have most of them equal. The only thing that we need to know is that the insides of these logs have to be equal, okay? And so I'm going to subtract my x. Let's get all the x's to one side. Negative 1 equals just x plus 1. If I subtract the 1, I get a negative 2 equals x. And ladies and gentlemen, that should be my answer. Now, when I check this answer, here's something I want you to see. If I check this, I have the log base 2 of a negative 2 minus 1 equals the log base 2 of 2 times negative 2. Sorry, I ran out of room here, plus 1. I'm going to get the log base 2 of negative 3 equals the log base 2 of negative 3. Now, you want to say that the left hand and the right hand side are going to be the same, but there is a property here that says we cannot have any negative values in our log. So because it's the log of a negative 3, this is undefined. This would be an extraneous solution, and this problem has no solution. So this problem has no solution because when I substituted it in, the argument of the log turned out to be negative, and logs are not defined for any negative values. Okay, so this problem has no solution. Let's take a look at number 19. Okay, so for number 19, I'm going to get this natural log by itself. So I have the natural log of x equals 7. Now, remember, to get rid of your natural log, we're going to use the base e. So those cancel. So I get x equals e to the 7th. And that's really just going to be my answer. If you do e to the 7th in your calculator, again, I'm using my calculator here, we get a very, very large number, but don't let that scare you. I have 1,096.63 3. And this would be my answer. If we substitute that back in, it will work. You will get the answer of 35. And it might be a little off just because of rounding, but it is going to be a solution to our equation. Okay, so let's take a look at number 20. We have an exponential here. We're going to isolate that exponential. Let's get rid of this extra term here, this 4. So now I have a 10 to the 2x. There we go. Okay. Minus 3 is equal to, and 21 minus 4 is going to be 17. Now, to get rid of the 10, we have to use a log base 10, okay, of both sides. So 10 to the 2x minus 3 equals log base 10 of 17. Those cancel, and I just get a 2x minus 3 equals the log base 10 of 17. Again, I'm going to use the log base feature of my calculator, and I'm going to say the log of 17, or base 10 of 17, is going to give me a 1.230. So now if I add 3 over to the other side, again, using my calculator, I'm going to get a 2x equals 4.230. I'm going to divide the 2, and I get an answer of 2.115 approximately. And this would be my solution. Okay, and if you plug that in, it should work. All right, number 21 is very, very similar to number 16. We have 2 exponentials on either side. So what we need to do is we need to get those to have the same base. So I'm going to say 10 to the x minus 3 is going to equal 10 squared is still 100 to the 4x minus 5. So I have 10 to the x minus 3 is equal to 10 to the 8x minus 10. Same base, so now we can just solve what's left. Okay, just the exponents. If I get all of my exponents to one side, so I have a negative 3 equals 7x minus 10. Add the 10 over, I get 7 equals 7x. Divide the 7, I get 1. And then that would be my answer. If you substitute in, it will work. That will be your solution. Now, number 22 is a little tricky. We have to watch out for this one. All right, we have 2 logs. All right, so what I want to do is I want to condense everything that's over here. So I'm going to start by making this an exponent. So x squared minus log base 4 of x minus 1 is equal to 1. Now I have subtraction, so I want to use division here. So I'm going to say the log base 4 of x squared over x minus 1 is equal to 1. And now that it's all in terms of one log, we can get rid of that log, right? So I'm going to use base 4 of both sides, right? So 4 to each power. These cancel. So now I have this rational expression, x squared over x minus 1 equals 4 to the first, which is just 4. So if I'm going to solve this, I'm just going to put this over 1. I'm going to cross multiply. Now I'm running out a little bit of room here, but we're going to see what I get. I'm going to get 4 times x minus 1 is a 4x minus 4 equals an x squared. If I bring everything over to the side of this quadratic, now I'm going to change colors, so I'm getting a little messy. I'm going to get something like x squared minus 4x plus 4 equals 0. And then I would have to use something like quadratic formula or factoring to solve it. At this point, guys, the question on your assessment will not be that difficult. But we do know how to solve quadratics. I want you to keep that in the back of your mind so that we can solve this and get a solution. Okay. For today, for the EOR, you can leave it as that. For the assessment, your assessments questions will be like the ones above. Okay. They won't be that involved. Okay. And actually, we can, if you wanted to, you can skip the rest of this. So you can just end on 21 or 22. And that should be enough to get you ready for this assessment. And I hope you guys are all doing well. Please email me with any questions. I will post a blank version of this EOR so you can try to do it, or you can try to do it along with the video. And then when you're completed, just let me know and I will send you the assessment.